Um, this is a continuation video that I am going to do that was kind of got its start on the previous video where I showed my sensors being set up on my smart garden. So I have, if you remember on the previous video, I had one temperature sensor and four moisture sensors that are part of the gardening box that I have, and that's basically going to be set up inside and connected to a device that is being controlled via containers. So with that said, before I actually do any kind of commands running all the containers, I'm going to kind of go through exactly what each container represents, maybe kind of do a little bit of the source code view, just a small simple thing, and then I'll actually get into another video where I actually run these containers. So the three containers I actually have running inside the smart device is my Garden API image, my Python moisture container image, and then my Python temperature image. Okay. The most elaborate one is the Garden API image. This basically has persistent storage. It's going to host a website that's going to have all the content rendered eventually. And it also has a maintenance script that runs inside of the container as well that basically kind of gets all the different moisture endpoints or moisture values and then checks to see if it needs to do any watering. So it's a Node.js environment, and but it has a Python script that is invoked from on a Chrome tab. So I'll go ahead and go through this first. So for starters, right now this is primarily just a typical Docker image. As you can see here, here's a Docker file, but we also have a pod.yaml. Okay. Now, mind you, the pod.yaml I'm not going to really go through extensively right now because that is a Kubernetes requirement. And right now, this first deployment on my smart device is not going to be Kubernetes because the device is not Kubernetes compatible yet because it doesn't have enough memory. Anyway, but we will go over the Docker file here. So here's a typical Docker file. Now, again, this is a Node.js environment. So because I'm using a smart device, I have to use a small image called Node 14 Alpine, which is basically a very simple Node image where I can pull all the environments in. If I wanted to run this from my computer, I could actually run the full Node environment in itself. Okay. I also have my maintainer name here. And then I have I run an APK update, which basically installs everything for this. Now, mind you, APK meaning we're running this as a Ubuntu type of OS. So Ubuntu is actually running under the Converse, which then installs everything here. So after that, I installed a little bit of root privileges, and then I set up a time zone data library inside of it as well because we need to make sure that we're synced with the local time zone. I also then run some Linux headers, which are basically required to run some of the other Python mechanisms later on. After I install the Linux headers, I then install Python 3, a few different type of compilation libraries as well, and then I go from there. After that, I install pip3. Pip3, as many will know, is a good package manager that we used for install other things. Then after that, I install my typical library for GPIO. GPIO in this case is basically we're going to be controlling different things like temperature sensing. We're going to be getting data from a moisture detector, and we're going to feed that into the GPIOs. Later on, I will also use this to trigger a relay to drive the moisture and drive some watering on the plants. Here's the directory that I'm using to create the app, okay? And then I copy all my content that's here in this directory into that app. I run npm install, which basically installs the Node.js dependencies, and then I set my time zones data here. After that, I expose my port 8080, which makes sure that's available, and then I run the container, okay? So this is all inside of the Docker file image, okay? So as soon as we install this inside the Docker area there inside the device, this will run all these steps. All right, so here is the app.js. This is the most important because this is a full web RESTful services integration. I have a simple root API call here, which basically just says, welcome to the Molini Garden app. And then also have another GET request that basically will respond with data. And all of this data is basically populated from all of the other containers. So it will pull data from these two JSON files, whether it's products or data.json. Data.json comes from the data that's coming from the other containers. Now, mind you, this is a simple app. I'm not using a database. Not on a normal upper scale application, I would not recommend to use just a standard JSON file. But in a case like this, where we're basically just a small app, we're trying to just do some small similar things, a JSON file is perfectly fine. All right, so back to the app.js. If we do the get data call, which I will demonstrate later on in another video, we would populate all of the JSON into the response. This post data is basically used for all the other containers. So every time it sends an IP, every time the other container sends an IP address request to a post, this is the URL they're going to hit. If it's a temperature request, it's going to be populated into the products file. If it's another type of request, it's going to go into the data file, and then it's written as well, stored. Here's all the other. Here's the listener for the application. Then I also have my cron schedule, which launches the maintenance script on initialization of the Node.js app. Pretty simple stuff, so not hardcore brain science. Next thing is, let's go over the Python script. So this governor is one of the first GPIOs, and this is the one that's actually invoked from the app.js. So first thing that happens is once this governor is launched, it will open the file for the data, then it'll open the products file, and then it will start the process of checking to see what values are in place. It'll check for the ID for the past variable it is sent in, then it'll check for the temperature bottom and temperature top, and the last time it was watered. Each product within the garden has a specific set of parameters that has to be set for optimal growth. So we have to set those and use those to be used as a watering schedule. So in all cases, we're always going to be setting a GPIO out here in this case, which was going to be for our watering mechanism. But we also have to make sure that the temperature is above 32 degrees. If it's above 32 degrees, then we're good. If we're not, we don't want things to freeze, so we just don't do it at all. If we do find it is above 32 degrees, we go and check to see if the current temperature is going to be temperature top. Now, mind you, this logic is a little bit antiquated. I'm going to have to change it because basically what I'm thinking of is in the future soon, because Texas gets so extreme in temperature as well, is whenever I find out that it's above the temperature top, I'm just going to do a simple watering just to kind of do a little bit of a dusting of water onto the products so they make sure that they stay nice and cool. I mean, temperatures here could be really extreme, so this is kind of a very important feature here. If the temperature is at an optimal zone, then I'm going to just do the normal water schedule, which basically sets at a certain water duration here as well. Okay? And then, of course, if we're less than the optimal zone, but we're still above 32 degrees, then the stretch of time for water is a little bit different. Okay? All right, so, and these will be changed as well in the future as I make adjustments. Next garden image is going to be the Python moisture container. And as before, we have a simple Python image file, which we use to basically run a lot of the same installments as we saw in the Node.js environment. However, this time we're using Python Slim, okay, instead of Node.js. And then we're also installing pip as well, but if you notice as well, we're not actually using a Ubuntu container. We're actually running this as a typical install on a Linux that's not Ubuntu. So, not a lot of files to be added here except for moisture. And then, of course, we're setting the time zone for the local area where it's at, and then what happens when we launch. So, this container basically is going to be used multiple times by multiple products. So we have it. So every time when it launches, it's going to get a new set of arguments that basically launch in this case. Here's the moisture, and here are the arguments that are being passed in. Here's the type of setting that we're doing. It's going to be all input. So moisture basically is what's going to happen is if moisture is detected at this level, it's going to be a 1, or I'm sorry, it's going to be a 0. If it's dry, then it's going to need moisture. Then it's going to be a 1, and then from that determination, we send all that information into the Garden API image, and then the governor script basically does a calculation of what it's going to do with it later on. So it's pretty simple script, but we have to basically make it all separate for each different product. The Python temperature file, or container image, has a lot of the same characteristics as before, except we have a specific type of framework that we're using for the temperature. So in that case, we only install that one specifically. The rest of it is pretty much practically the same as the moisture package. In the temperature.py, we are passing in one argument, but then we're also getting one reading of humidity and temperature. We're only actually making a calculation on temperature and then feeding it into the request that is sent to the garden container. We're not actually doing anything with humidity right now, but I plan on actually doing that coming soon in the future. Right now I'm actually using GPIO2, and that's actually to be used for that could be any GPIO as long as you have it assigned, but in this case we're only going to be using 2 only. Alright, so that's pretty much it. The 3 containers, as I mentioned, my plan is to actually get a web app produced to be populated in this public folder, which is actually going to be this right here, but I haven't gotten to that point quite yet. And what's going to happen is I'm going to display all the JSON content onto it, plus I'm actually going to institute cameras to where I can do object modeling. But that's in the near future. For right now, these are the 3 containers, and we're going to go from there. Let me know if you have any comments. Stay tuned for the next video as we start running these containers on the device. Talk to you later.